Hey folks, welcome to Calculus Daily, episode 17. Apologies about the delay in the questions. What I would recommend you to do is pause when the questions appear, work out the answers, and then check with my working. Okay, today we're all doing achieved questions. So the first question is, given that x minus 2 is a factor of gx, find the value of p. Because we have x minus 2 as a factor, we could use 2. So in other words, g of 2 should equal to 0. So substituting everything into the equation, we're going to get 0 equals 2 cubed minus 2p 2 squared plus p times 2 minus 5. Simplifying this, 2 cubed is 8, minus 2 multiplied by 4 is minus 8p, plus p times 2 is 2p minus 5. Simplifying this, we're going to get 8 minus 5 is 3. Minus 8p plus 2p is negative 6p. So rearranging, we're going to get 6p equals to 3 and p is equal to 3 over 6. Therefore, p is equal to half. All right. So that's basically your first question there. Now with the second question, I've got u is equal to 3 minus 3i. So I'm going to first draw that. So 3 is there, negative 3 is there. And my complex number looks like that. So I know what the argument is. That's going to be minus 45 degrees. Now if you want to know why, take a look at this triangle here. So we have 3 and 3, and of course this is an isosceles triangle, therefore that's going to be 45 degrees. And now as for the modulus, which is r, that's kind of like working out the hypotenuse. So r squared is equal to 3 squared plus 3 squared, r squared is equal to 18, r is equal to square root of 18. So, because we have u is equal to 3 minus 3i, we can write u as square root of 18 cis negative 45 degrees. Okay, so once we have that, now we can apply De Moivre's theorem. So u to the power of 4 equals square root of 18 cis negative 45 to the power of 4. So we're going to end up with square root of 18 to the power of 4 cis negative 45 degrees times 4. Now square root of 18, that's equal to 300, square root of 18 to the power of 4 equals 324. Cis negative 45 times 4 is negative 180 degrees. And that's how you do that second question. Cool. Off we go to differentiation, folks. Okay, so the first question in this case is asking us to differentiate y equals 5 cos 3x. So then we can write y dash is equal to 5. Cos 3x gets differentiated as negative sine 3x and multiplied by the differentiation of whatever's inside the bracket, which in this case is 3, which means we can leave our answer as negative 15 sine 3x. Okay, that's your first question. Second question is asking you find the gradient of the normal to the function y at the point 1, 4. So obviously I need to differentiate this function. So if I was to write f of x is equal to 3x squared minus 5x to the power of 2, then f dash of x is equal to, I need to use chain rule for this, so I'm going to get 3x squared minus 5x to the power of 1 multiplied by the differentiation of whatever's inside the bracket, which in this case is 6x minus 5. Now this is the gradient function, so I need to find out what the gradient is at just point 1. So I need to find f dash of 1. So substituting 1 in this equation, I have 1 squared minus 5 times 1 multiplied by 6 times 1 minus 5. So I've got 2 multiplied by, what have I got here? I've got 3 minus 5, which is negative 2. Get rid of the little thing there. Multiplied by 6 minus 5, which is 1. So in the end, my gradient is equal to negative 4. So if my gradient is equal to negative 4, then the gradient of the normal is going to be -1 over m. So in this case, the gradient of the normal is going to be -1 over -4, which simplifies to 1/4. So that's what the gradient of my normal at that point 1/4 is. Okay, that's differentiation. Off we go to integration. Alright guys, so with this question, we've got 2 over x minus 3 over x squared. So I'm going to write this as 2 over x minus 3 to the power of x to the, 3 times x to the power of -2 dx. So when I integrate this, 2 over x could be written as 2 ln of x minus 3x -2 plus 1 and divided by -2 plus 1 plus c. So this, the first integral there, when we integrate it, we're going to get 2 ln of x minus 3 to the power, no, sorry, I keep saying that, 3 times x to the power of -1 divided by -1 plus c. And if you really want to simplify this further, we're going to get 2 ln of x plus 3 over x plus c. Okay, that's the first one. The second one is asking you for find the area enclosed between the graph of y equals 3 sec squared x, the x-axis, and the lines where you've got those two little lines. So writing this as an integral format, I'm going to get pi over 4 at the top, pi over 6 at the bottom, and I want to find integral of 3 sec squared x dx. Okay, so integrating sec squared x, I'm going to get tan x. So in this case, when I integrate this, I'm going to get 3 tan x, and that's between pi over 4 and pi over 6. So from here, substituting my two values, I have 3 tan pi over 4 minus 3 tan pi over 6. Now when you put this in the calculator, you should get 1.27. If you were going to do this just using your special triangles, you might also get the answer of 3 minus 3 over root 3, or simplifying this further, you might just get 3 minus root 3. Okay, and that's basically it for this session, guys. Just all achieved questions. As you can see, we're doing this quite fast, so it's just a matter of keep practicing these questions, and you will find that you start getting better at it. All right, so that's it for this session. Thank you for watching, and yeah, keep your eye out for tomorrow's episode.